Greetings! Welcome back to Old Ways Rising Farm YouTube channel. Today we have a bunch of planting containers and we're going to talk about how to use these properly. If you're doing a lot of gardening, plant propagation, anything like that, you're inevitably going to run into the use of these gardening containers for your plants. Whether it's for a longer term grow out to get something large enough to be able to fend for itself in the wild, or a container garden for an annual, or just growing out some tomato seeds that you're going to transplant fairly quickly. We need to consider the pot. The soil you put your plants in is important, but there's a lot of complexity in making the correct soil mix. That's for another video. But if you take the same soil mix and put it in all three of these pots, you're going to have different behaviors and favor and disfavor different plant growth characteristics. So it's more than just the soil. The geometry and size of the pot also matters a lot. So that's what we're going to talk about today. I do want to put in, just real quick, we're not going to talk about the art and design aspects of choosing a beautiful pot. That's up to you. I'm not so much an artistic design guy that I'm even really competent to describe those principles, but I can give you the science and understand what goes into your sizing and shape of the pots. So after you make those design decisions, then you can go and get something with dimensions that will suit your needs and the biology of the plant. Okay. So first of all, we want to talk about pot size. Now, a plant will always want to maintain a set root to shoot ratio. The most common root to shoot ratio is 50-50. So when you're looking at a plant, if you don't know anything else about the plant, if you're looking at a plant saying, what size pot should I use? Think about the size it is now. Think about how much growth you're going to get this year out of it. And however much top mass that is, you should have a similar bottom mass, soil volume. Now, you may have to kind of compress the plant a little bit in your brain, right? Because some plants are going to have a really lanky top and then more of a compact bottom, okay? So you may need to kind of imagine folding the plant a little bit if it's just a straight up whip, right? Think about accordion folding it 3 times in your brain. Don't literally do it to the plant. And then that's your plant volume, your soil volume, okay? So, you know, if we look at these little guys, these little spruce seedlings, when you take these up out of the pot, the roots will be almost a mirror image of the top, okay? This is this is pretty much universal for all of your fibrous rooted plants and spills over into heart rooted as well. So you're looking at this, you know, you can kind of think how tall it is. Give it that size pot, okay? About the same height and width, okay? And that's about where you would want it to be. And that'll give it a little bit of room to fill out and expand its root volume this year. Pretty easy. Now, when we talk about taprooted species, usually for a taprooted species, the root volume will be 1/3 larger on the small side and fully double on the upper end of the spectrum, okay? So if you have, you know, a foot of plant, you need 2 feet of root volume. That's where pots of this shape really come in, okay? So if you're growing a taprooted species in this pot, even though it's a fairly large, substantial pot, you can only grow a taprooted species in this until it's about 4 inches tall, and then it needs transplanting because of that root to shoot ratio and how it's different with taprooted plants than non-taprooted plants, okay? So this is going to come in when you're thinking about things like oak trees, chestnut trees, things like that. Those are all extreme, pretty much all of your nut trees. Those are extreme, just some examples of extreme taprooted species, right? So this 2-foot tall pot can accommodate a 1-foot tall plant, and then it needs to go in the ground. So those are different. You have to know that when you're considering pot size. There are some plants that will have a smaller root volume than the top, but that's uncommon. And usually you're into something like a cactus or like a wetland plant where the water dynamics are radically different from what's in your average soil. So in general, look for a pot that's going to allow about the same root volume as the current plant plus this year's growth, and you'll be in pretty good shape. Also, keep that in mind when you're going to a nursery and purchasing plants in pots like this. Okay? All of these are reused nursery containers. Some from plants that I've purchased, some that have just been given to me because my neighbors will say, "Hey, you want these pots?" I'm like, "Yeah, I want those pots." So, you know.
Always.
Always save your pots, right? These are very, very useful. But if you're looking at a plant in a pot, again, imagine folding the dimensions of that tree into the pot. If they fit comfortably, it's a good tree. If they don't fit comfortably, and you have a really, really gargantuan tree in a really small pot, can you buy it and grow that tree? Yes, but you're talking about advanced plant propagation techniques being needed, because you are going to have severe transplant shock, because it will be severely root bound. So you're going to need to do more than just score the root ball, thunk it in a hole, and forget about it. You're going to have to watch it. You're going to have to water it. You're going to have to do some fancy fertilization. You're going to have to do a little bit of sometimes unfold and work with the roots. You're going to have to do a little bit of fancy stuff to get it through that transplant shock. It's very common when you walk around a nursery, you'll see people picking out the best plant, and they're always picking the biggest one. Completely wrong. When you see that, you know that person doesn't have a clue about what they're doing. Okay? You actually, if you have a row of 10 apple trees, the smallest one in the row will come through with the least transplant shock. And 2 years down the row, that small tree will be indistinguishable from, or will have outgrown, the big one that somebody picked out as the best. Okay? Because of the root to shoot ratio issue. So, think about that, both when you're buying trees and when you're potting your own. That's your guideline for the size. 50-50 root to shoot ratio. Unless it's tap rooted, then you want double. Like, so if you want a 1 foot tall chestnut tree, it should be in this pot, literally this size. Okay? If you find a 3 foot tall chestnut tree in something this size, you're going to have to work with it. I have done that successfully and grown them, but you're going to have to work with it. You're going to have to use some fancy shenanigans to get them to come through. Okay? So that's pot sizing. Now pot shape. Other than the tap-rooted trees, this is a specialty pot for tap-rooted trees. Other than that, the shape influences water retention. Okay? The soil influences water retention dramatically, but also the shape of the pot does. You have to understand the 3 fates of water when you water a plant in a pot. One is water is absorbed by the soil as hygroscopic water. Okay? So this is where the soil particle, water is a polar molecule. Your soil particle has a lot of polar stuff in it. They attract each other, and the water is loosely, or sometimes not so loosely, bound to the soil particle. Okay? That's true absorption of the water. That's the first fate. That is determined entirely by soil volume and soil composition. The pot doesn't have much to do with that. But the second fate is the interstitial water and the meniscus water down the sides of the pot. Okay? This is where the pot starts to have an influence. Because water, being a polar molecule, will stick to its container. You can prove this to yourself. Take a clear glass of water with straight sides, put some water in it, and then look at the line. And you'll see the water will crawl up the walls of the container. Right? So if you have your glass of water, the water's going to come up, it's going to kind of come down into you and then crawl back up the other side. That's called the meniscus. And it's a property of the surface tension of the water. Okay? So water is adhesive, and it's going to adhere to the surface of those particles. The glass does not absorb the water, but the water will still adhere to the surface. This is why sand becomes wet. The sand particles are very good at letting water stick to the surface, even though they don't absorb anything. Okay? So sand will remain moist for a time because of that surface tension adhering to the outsides. And that surface tension is strong enough to glue the wet particle of wet sand to your leg as you walk down a beach. So it really is a pretty strong force. That allows for interstitial water to just kind of cling in the airspace in between a couple soil particles, but also between the soil particles and the wall of the pot. So surface tension matters, and the composition of the pot matters. We'll get back to that in a second. The third fate of water is gravitational water. The gravity is going to pull down on the column of water, pull it down through and out the holes in the bottom of the pot. Kind of goes without saying, your pot's going to have holes in the bottom somewhere. If it doesn't, it's not a good flower pot. Add holes or get a different container, please. Okay? So, the ability and efficiency with which gravity can pull water down through the soil is determined on the height of the column of water. The higher the column of water, the more pressure that column of water exerts downward. Okay? So all three of these pots are similar in volume, but they will, not exactly identical. This one I think has the most soil volume of the three, but they're pretty similar, okay? But they will interact with water differently because of that fact I just shared. The taller the column of water, the more efficiently gravity can pull it through the pot. So, given identical soil mixes, identical water regime, this pot will hold the least water because it's the tallest column and gravity can pull water down through most efficiently. This pot will hold the most water because it's short, squat, and flat, so it's a shorter column of water. The pressure is less. So it will take longer for the gravitational water to move through, and less will be retained. Okay? That's why we use these for plants that want wetter feet. Okay? So these are usually called azalea pots. These squat pots are usually called azalea pots. Rhododendron, azalea, blueberries, things like that. Their roots are adapted to rapidly shedding water so that they don't suffocate. Roots need air as much as they need water. They have to exchange gases. Plants that are adapted to this permanent standing water, like cattails, reeds, mangroves, bald cypress, right? All of those plants, they will either have internal airspace so the root can exchange gases internally, or, like the bald cypress, those knees are kind of acting like a snorkel so that you have some vertical area that can exchange gases and prevent the suffocation of the root. If water clings to the root for too long, then the root suffocates, then it dies, then it rots. So people will say, I overwatered my plant and the roots rotted out. That's not real. That is the end result, but it's not quite the chain of events, right? First you suffocate, then it dies, then it rots. The living root doesn't rot out, okay? This is where that meniscus starts to matter. Plants that grow in like not standing water, but the margins of a wetland, like blueberries and azaleas and some things like that. There are drought-loving azaleas, yes, but the wetter lowland azaleas and rhododendron are what I'm specifically talking about here. Those sorts of plants, their root surface is harder to shed water quickly, so that the rain comes, it wets the soil, and as soon as that gravitational water is allowed to move through, because remember, we're at the edge of a wetland, so it's going to take longer, then they can dry out and exchange gases and get a breath of fresh air, so to speak, before the next rain. So they're adapted to shedding water away from the root. But that also means they need water more frequently because they don't absorb as much per rain event. Okay, so this pot is good for that. But then you talk about your drought-tolerant taprooted species. There are wetland-adapted taprooted species, yes, but again, we're talking about the big picture, not the little rabbit holes. But your drought-tolerant taprooted species, your succulents, your cacti, things like that, and even some wet climate plants that grow as epiphytes, like epiphytic orchids. They are adapted. They have roots with a sponge-like material which grabs and holds the water. Okay? Now they're coated in a blanket of water. If that blanket of water isn't allowed to completely dry and give the root its breath of fresh air before the next watering, the roots will self-suffocate. So that's where you need more drainage, both from better drained soil, but also a taller pot. Stop planting cacti in bowls. Okay? It's bad. You want to plant cacti in this sort of average pot, or even something that's a little taller, because you need it to drain away quickly. Also, this is a good time to talk about pot composition. Now, I know there's a bajillion and a half different things that people make pots out of, but all I care about for this is whether it's pervious or impervious to water. Plastics and glazed ceramics are all impervious. Wicker basket pots in general, sphagnum-lined baskets, and unglazed ceramics, like this guy, are pervious. Water can migrate through them. So now that interstitial water, instead of forming a meniscus on the inside of the pot, migrates through the pot and forms a meniscus on the outside where it can evaporate. That prevents it from holding water in contact with the roots. Look at a cactus that's been overwatered sometime. Pull it out of the pot, and the majority of the root rot will be right around the edge of the pot, because the pot holds that meniscus in permanent contact with the roots that are circling the pot, and it suffocates them, and then they rot out. So if you have problems with that, going to a water permeable container material is a good idea. And again, I'm not talking about what it looks like or what water permeable material you're using. I just care that it's a water permeable material. Your soil will dry out faster because you have horizontal water migration out of the root volume. But for a drought-dependent species, that's a good thing. Okay? This is why, like, cactus and orchids and stuff are usually going to do best in a basket or an unglazed ceramic pot. Okay? Because of that fact. So we look at it. This is for your water-loving, water-shedding roots. Okay? This is for your tap roots and drier plants. This is your average. On average, most plants are average, and that's why the average plant pot looks like this. The height is similar to the width. That's an average pot. Doesn't have to be exactly this. It could be cone-shaped. It could be flared out. I don't care about those specifics. When the height is fairly similar to the width, that gives you your average optimal water-to-air balance. And it is that balance. They need the water. They also need the air. Okay? Don't drown them and kill them. Right? And this is the best balance of that. Okay? Also, you know, when we're talking about this one, think about pictures of bonsai trees. The bonsai cultivation depends on keeping the tree smaller by inducing a root-bound condition and artificially dwarfing the tree through it. Therefore, you can't have a large soil volume, so the pots are always flatter, because it's less efficient for gravity to remove the water from that small soil volume, so it stays in contact with the roots just a little bit longer and gives them a little better chance at absorbing it. Okay? That's why the bonsai are always in like really shallow dishes. But that's bad for cacti. Don't do it. Okay? Stop doing cactus bowls. Anyway, that's the generalities. A couple of specifics. These things are horrid. Okay? I hate these. They are very convenient for retail bedding plants, But these guys, these 4-packs and 6-packs and other, I mean 3-packs, yeah, there's a bunch of different ones. But these things are a retail convenience, pure and simple. They are utterly terrible for the biology of your plants. Okay? Yes, I will buy plants in them, but I will get them out of them as soon as humanly possible. Okay, they're not enough root volume for anything except the smallest little midget plants. Like a hen and chick can live in these for a long time. But that's a special case. Your average plant is going to go root bound in just 2 to 3 weeks and then suffer mightily from then on. And the longer they're in here, the worse the transplant shock is going to be when you finally move them into your garden. Okay? So yeah, sure, if you need to buy plants in these, do it. But when you're starting your own seeds, don't do it. Do this. Right? This is how I start all of my seeds. This is just a pot that I grabbed here quick. These are a very slow growing species of spruce. These are actually 3-year seedlings now. But I do tomatoes and peppers and squash and all those sorts of things. Well, usually squash I direct seed. But anyway, I do all of those sorts of things this way. I'll take a larger pot, which has enough surface area to accommodate the quantity of seed that I'm using. This is another good place to use these. If I'm doing a whole bunch of tomatoes and I want to grow like 100 tomato seeds, I'll use one of these azalea pots for it. Just because I have more area across the top. Just sow the seeds across the top. When they're about this tall, these are ready to move on. When they're about this tall and they're easy to handle, plant them directly in your garden from them. Or, in a case like this where I want to give these a couple of years more growth so that they can fend for themselves better in the wild, I'll put them in pots. I'll put them in pots about half this size. Okay? So that's my recommendation. Forget that 6-packs exist and do this. It is much, much, much better for the biology of your plants to have a little bit more leg room. Okay? And then the other end of the extreme, and also a special case, are these really gargantuan pots like these guys. Okay? And we have sort of a conventional dimensions and an azalea pot example. I bought some really big blueberry plants in these. Again, blueberries like wet feet. Use the squat pot, right? Inhibit that gravitational water movement. These are a special case. When you're propagating trees and shrubs to plant out, as soon as they get to about this size pot, it's time to get them in the ground. It's not ideal to keep them growing longer than this. If you can't plant them in a certain year, sure, you can put them in here for another year just to buy some time. But this is where you really want to get them in the ground. The older they get, the more transplant shock they're going to suffer and the longer the time frame involved in their establishment, right? So once they're about this size, get them in. Stop messing around with the pots. Get them in the dirt. But there are special cases. One special case I'll run into is like if I planted a tree or shrub, it's suffering, it's not doing well, the spot isn't correct, or like a real world example, I planted some Christmas trees for my folks and the deer just mauled them and will not let them grow where they were going. So I'm going to dig them up and rescue them. These are really good rescue pots, right? If I'm going to dig them up, I want to put them in a pot for a while to watch them. I don't know exactly where they're going to go. I need to overwinter them a couple of years. These are really good for that kind of rescue because trees that have been in the ground, they're going to grow a lot of horizontal roots and they're going to need that room. So a big roomy pot like this is great for that application. The other special case where I'll use these a lot is if I buy a tree to be a mother plant, and I'm not buying it to plant right away, I'm buying it to propagate it and grow 5 or 10 or 20, whether it's like a cutting or an air layering or I'm going to graft off of it and grow 5 or 10 or 20 trees in this size. I'll put the mother tree in a big spacious pot like this because it will grow more vigorously, it will put on more growth, and it will be better and easier to overwinter successfully, okay, when I'm already starting with a large plant. So these are great when I'm just growing a tree for propagation material. Okay. Special cases on these. So I hope this gives you some ideas. If you've enjoyed this, and it has, I would be most grateful if you gave it a thumbs up, because that helps the YouTube algorithm know to show it to other folks. I hope that you will take some of these ideas and apply them to your own container gardening applications, because this applies just as much to, you know, container gardening and raised bed gardening, right? How big should your raised bed or your container be? Your above ground needs to mirror the below ground, right? So how big's your tomato plant above ground? That's how much space it needs below ground. The guidelines still apply. So I hope that you got something out of it, and I'll see you here next time at Old Ways Rising Farm.